Hi guys, welcome to another video. The topic for today is probability, right? This is in continuation with the three videos that we have done before this. So we have covered counting, permutation, combination, and logically this is the next one, which is probability. Okay, so without further ado, let's get into this, right? Now probability, see, when we talk about probability, right, what is it? What is probability? Right? Probability is chances of happening, right? Chances of something happening, right? Some event happening. Okay, so now question comes that okay, chances of happening, what does that mean, right? Say for example, if I tell you that there is a 80% chance that it will rain today, depending on various factors, I come up with that, right? So that chance of happening, right, that does not mean that it will definitely rain today, but what it means is that there is a 80% chance it might rain, right? So similarly, probability is chances of finding, chances of happening of something, right? So probability of event A, right, probability of event A is simply, right, favorable cases, right, when A occurs divided by total cases. See, in the previous case when we said there is an 80% chance, what did it mean? That out of 100 times, 80 times it will rain, 20 times it will not rain. So the favorable cases were 80, total were 100, so 80 by 100 became 80%, right? Similarly, probability of any event happening, right? A could be any event depending on the question. So probability of A means, right, what are the cases or the number of favorable cases, number of cases, right, when A happens, right, divided by total cases, right? Whether A happens or not happens, total cases. This is what is probability. Okay. Now, if you think about the same example, so when I say there is a 80% chance that it will rain, what is the percentage chance it won't rain? So we say 20%, right? We say 20% because we do 100 minus 80. So probability of A naught, which is not happening of A, is simply 1 minus probability of A, right? Probability of A naught, that is not happening of A, right, is simply 1 minus probability of A, which simply tells you that probability of any event, right, probability of any event is always between 0 and 1. Okay, because the chances of something happening are maximum 100%, right, not happening is 0%. Let's look into it slightly more in for further detail. So what we are trying to say is that chances of something happening, right, what is the maximum chance of something happening? That's 100%. This is maximum, right, whereas not happening is 0%. 0% means it won't happen at all, right? So this is your minimum chances, right? So probability or the chances of anything happening or not happening will always lie between 0% to 100%, which simply means that probability of any event, right, lies between 0 and 1. 0 means it will never happen, 1 means it will always happen. Okay, right? So I hope you understand this. Now, okay, let's recap. We have learned that okay, probability of something happening, right, probability of an event A is favorable cases of that event happening divided by total cases, right? Now obviously a logical question comes, okay, fine, if it is this simple, then how do I solve? Like, the problem is, how do I find favorable cases, how do I find total cases? That is where the problem lies, right? So again, let's go back to the theory that we have already done. See, probability, right, as we discussed, is favorable cases by total, right? Now all you have to do, right, all you have to do is recall your concepts of the previous topic. Okay, how do you find favorable cases? This is what we have learned in the previous three videos, right? We either use the concept of counting, we use permutation, or we use combination, right? Favorable cases is what we have found in the previous three topics. Okay, the entire questions of permutation combination, those are what? Finding how many arrangements are possible, finding how many selections are possible, finding how many cases are possible. Those are all favorable cases. Okay, and whatever you use here, you use the same thing to find total cases as well. Okay, so for example, if I am using permutation to find favorable cases, then I will use permutation only to find total cases, right? So again, you use the same method to find total cases as well. So essentially, probability is simply whatever you have learned in the previous three videos, all the questions that you have solved there, divide each answer by total cases. That's all. Divide each answer by total cases, and all your questions get converted from permutation combination counting question to a probability question. Okay, so simple probability is fraction. Okay, what you want out of total. How do you find what you want? Using permutation combination or counting. How do you find total? Using the same method. What you want by total simply becomes probability. Okay, so don't get worried, don't get scared of this topic. As I told you before as well, see, this topic is 50% mental. Okay, if you're able to understand, if you're able to figure out what to apply, how to apply, right, solving will become very easy, right? So again, if I recap, what do we do whenever a probability question comes? Okay, whenever a probability question comes, do not be worried, do not be scared. Simply, right, the easiest thing to do is first find total cases. Okay, the first thing you can do is always simply find total cases. Okay, how will you do it? As I said, counting, permutation, combination. Remember, whenever we are looking for total cases, there should be no condition involved. Okay, there should be no constraints or conditions involved. Okay, once you have done that, tell yourself, okay, this is my denominator, right? These are the total possibilities. Now what is it that the question wants? They want probability of something, a, b, whatever happening, right? So then we say, okay, fine, whatever method I used here, right, using the same method, now find what is it, the number of cases, right? Find number of favorable cases. Okay, once you figure out what are favorable cases, now just divide the two. Okay, divide the two and you have probability of whatever they want, right? So remember, probability, do not be scared, do not be worried, it is very simple. Okay, we just do favorable by total. Think of it like an extension of a permutation, combination or counting question, right? Here, instead of doing one step, we are doing two. We are figuring out the favorable cases, and at the same time we are also figuring out the total cases, and then we simply divide the two and we have probability. Okay, let's look at some example, okay, to understand this in more detail, right? Say I tell you, right, okay, we have done this, we have covered this question before. Say I tell you that there is a student, okay, and he wants, right, he'll be, right, taking tests. Okay, there are 5 students in a batch. Okay, let's convert that to the same example, right? There are 5 students in a batch. Okay, we conduct a test for quant and verbal. So there are 2 tests that are happening, a quant test and verbal test. Okay, now I want to know the probability that, and again, for the best performer we will give a prize, right? Best performer, we give a prize, right? Now the question is, what is the probability that we give prize to 2 different students? The prize is given to 2 different students. Okay, now again, probability, right, 2 different students is favorable cases, right, by total cases. As I told you, let's focus on total cases first, and for total cases we don't look at the constraints. So again, think, is repetition allowed, not allowed, It is allowed because you as a student can get a prize in both the tests. See, you can perform, you can be the best performer in quant also and verbal as well, right? So for total test, I know repetition is allowed. Repetition is allowed means I will do counting. That's 5 into 5, right? 5 options for quant test, 5 options for giving prize for verbal test, right? Now what do I want? I want favorable cases. What is favorable cases? Two different students should get the prize. Now that I have done counting here, I will do counting on the top as well, right? I won't change my formula, I won't change my method, right? I'll do the same, I'll apply the same method, right? So for quant, any 5 can get, right? And because we want two different students, for verbal, the same student can't repeat. So the options for verbal will be 4, right? And now you simply solve this, you get the probability, right? So you realize it's exactly the same what we did in counting, right? But just divide favorable by total, right? Right. Similarly, let's look at another example. See, this was counting. Let's look at another example. Say we tell that I want to make a 5-letter word. Okay, we have apple. These are the 5 letters. I want to make a 5-letter word. Okay, the question might ask, what is the probability that vowels are together? Okay, so it's the same. Now think about it. Repetition allowed? No. A can't repeat again and again. Order matters? Yes. So this is a permutation question, right? This is a permutation question, right? What do I do? Probability of vowel are together. Sorry, right? That's again favorable cases. Favorable cases means vowel together by total cases. Again, I focus on total cases first. This is redundancy, right? So total cases will be 5p5 by 2p2, right? I first solve for total cases, which is 5p5 by 2p2, right? And then what do? I want favorable. Favorable is vowels together. Vowel together means I combine them, count them as one. Remember, try to recall all of that, right? Now we simply do 4p4 into 2p2 again by 2p2. The 2p2 comes because of redundancy, right? And all you have to do now is solve this. This is 48 by 120. That's 2 by 5. Okay, so again, the point I am trying to make, guys, is that don't treat probability as something different, something very difficult. Okay, it's a very simple thing. It's a simple extension of permutation, combination and counting. Okay, all you have to do is, probability is a fraction. Whatever you were solving for before, that divided by total, that is all. If you think like this, right, you will find solving for probability very easy. Okay. Alright, so if you try and concentrate, you will realize what are we supposed to do? There are 20 raffle tickets. We want two, right? Chosen random from chart. Probability that both have odd numbers. So we are taking 2 tickets, right? That's my event. But what do I want in that? I want both the numbers to be odd, right? So the question is, we have to find probability that both numbers are odd. Okay, again, that simply means favorable cases by total cases. So favorable is both are odd, total is, like, I just take two numbers, take two, what do you say, tickets, right? That's it, right? Again, as I said, when you think in terms of total, constraints are not there, it's just anything can come, right? Now let's classify the question, because I will try to find the total first. From 20, I just have to take 2 tickets. Now think about it, can repetition happen? Answer is no. Is order matter? Like, does the order matter? Again, the answer is no. I take ticket number 1, then ticket number 5, or I take ticket number 5, then ticket number 1. They are the same thing. So we will use combination here, right? So again, total, I have 20, I need 2, so that's 20C2, right? Total, there are 20 tickets, I need 2, so total becomes 20C2. Now you go with what is favorable. What do they actually want? So they want both the tickets to be odd. Okay, fine. How many odd numbers are there? 10 odd numbers are there. How many do I want? Again 2. See, we used combination at the bottom, so we have to use combination at the top as well, right? And now all you have to do is solve this. Okay, 10C2 is 10 into 9 by 2. 20C2 is 20 times 19 by 2. Okay, if you by 2 cancels out, this becomes 9 by 38, right? 9 by 38. If you want, this by 2 cancels, 10 and 20 cancels, 9 and 38, right? So answer becomes 9 by 38, right? Again, the point I am trying to make is, don't be scared of this topic. It is very simple. It is your job, it is our job to make it simple for us. Remember, probability is simply favorable by total. Let me find the total, let me find the favorable, then I simply divide. Okay. Alright, so if you understand that, let's dive deeper into the concept. Now, see, that was probability of a single event, right? Single thing happening, right? Now, what if we move to two events? Right? Probability of two events. No problem. So we classify event A, right? Something happening. Event B, something else happening, right? Then the question will come, what is the probability of A or B, right? Or probability of A and B. Okay, these are the various things that we can get, that okay, both the events are happening, one of the two is happening, both are happening together, both are not happening, right? Only one is happening, right? Or either or is happening, right? So this is probability of two events. Okay, again, you do not need to worry, we have already covered this. If you think about the concept of overlapping sets, okay, if you think about the concept of overlapping sets, right, or Venn diagram, right, we have covered the concept of two events there, right? This follows that. Okay, this entire concept will follow that. We will not learn anything new, we will learn whatever we have done there, but we'll just convert everything into probability. Now we already know probability is just a fraction, every value divided by total, right? So nothing changes, everything is the same. We are just converting it into the terminology of probability, right? So see, probability of A or B, which is theoretically also called A union B, right? Union, right, means either A or B. It also means at least A or B. It's the same thing. Either you say either A or B, or you say at least A or B, it's all the same. That simply means union, right? And we know from the formula, this is probability of A plus probability of B minus probability of A and B both, right? This is probability of A and B, this is probability of A intersection B, right? This means both happening, right? If you think about it, right, we learn this from a Venn diagram, right? This is event A, this is B, this is total, right? We write W X Y Z, right? Right. So probability of A union B, right? If you remember, A union B means X plus Y by Z, right? X plus Y plus Z. Probability will become by total, which is simply X plus Y plus Z by total, which is W plus X plus Y plus Z, right? Is probability of A. A is X and Z, so that is X plus Z again by total, plus Y plus Z, which is again by total, minus Because Z has been counted twice, you need to subtract Z once, right? So if you see, probability of two events is nothing new, it's nothing different. It's the same Venn diagram that we made and learned. It's the same representation. Okay, there we just wrote A union B is A plus B minus A intersection B. Here we have just added the sign probability before it. What changed because of writing probability? Now you just have to divide by total every time. Okay, and that is all. Probability of A intersection B, that is Z, because A intersection means Z, right? And again by total, right? Again by total. So when you talk about two events, okay, nothing changes. Okay, nothing changes. You just say, okay, event 1 is A, event 2 is B, A and B are two events. What is it that you want? You can draw your Venn diagram, use the same formula to solve. Again, question comes, how will I find probability of A? That we have already learned just now, right? How do I find probability of B? Again, we have learned that just now. How do I find probability of both happening? The favorable case changes, but the method remains the same. If you are using permutation, use permutation throughout, combination, combination throughout, counting, counting throughout, right? So remember, nothing changes. Okay. Now, if you are able to recall the concept, or if you are able to connect it to the previous one, you will also remember that we used to make a matrix or a table method for two variable Venn diagrams, right? So for the same thing can be done for probability as well, right? We simply write probability of happening of A, probability of A naught, which is not happening of A, and total, right? Then probability of happening of B, probability of not happening of B, and total, right? So we just make our table the same way, right? Total you know is 1, because total probability is always 1. This means probability of both, right? This simply means probability of A also happening, B also happening, so this is both. This means probability of A naught intersection B, that is only B, not A. Similarly, A intersection B naught, that means only A. This combined is total probability of A. This is total probability of not happening of A. Total probability of B. This is neither A naught intersection B naught. That is neither, none of them happening. Probability of B naught and 1. Right? So if you see, whenever two variable questions come, it is your choice. You can either use the formula, you can make the Venn diagram, or we learned this, right? We learned this matrix method when we did overlapping sets. So you can use the same method here as well. Okay, these are the definitions of each columns and each row. Okay, or basically each matrix. Okay, and you can apply the same thing exactly the same way. And again, I am telling you, how do I find probability of ABC? Use permutation combination, favorable by total, and all you have to do is put values here. Okay, alright. Now if you understand all of this, then let's move to the types of events. Okay, types of events. Now the types of events are very simple. There are 3 types. Okay, number one, we have mutually exclusive events. Mutually exclusive means what? Exclusive, right? Nothing in common. It simply means the two events have nothing in common. So mathematically, what does that mean? That the intersection part is 0. Okay, mathematically what that tells you? That intersection is 0. So in your Venn diagram, there is nothing in common. If I have to draw a Venn diagram for this, it will be, this is event A, this is event B. Okay, this is event A, this is event B, nothing in common. Okay, you can have neither here. It is possible both of them don't happen. Okay, that is possible, but there is nothing in common between the two. Okay, similarly, right, if we do mutually exhaustive events, okay, mutually exhaustive events, right? Mutually exhaustive means, Again, the word exhaustive means you cover everything, right? It's say the syllabus is exhaustive or the resources are exhaustive, means you cover everything. Cover everything means, right, P of A union B is equal to 1. That is, A union B, A or B covers everything. In another words, in simple words, the neither part is 0. So always either A will happen or B will happen or both will happen, neither will become 0. Okay. Again, if you want to draw a Venn diagram for the same, right? So A will cover everything, B will cover the rest. This is A, this is B, total. The neither part is 0. Okay, they can overlap, intersection can come, that's not a problem, but the neither part will be 0. Okay, and finally the third type, that's independent events. Okay, independent events means happening of one does not affect happening of the other. Okay, happening of one has no bearing on the happening of other. For example, say you and I sit and solve a question, right? So your solving has no bearing on me solving, right? You will solve yours, whatever it is, right? You will have your own probability of solving it. I will solve it my way, my own method, my speed, right? A different probability. Whether or not you are able to solve has no bearing on whether or not I can solve. Okay, right? So independent events. Now what happens in independent events? Probability of A intersection B is probability of A into probability of B. Remember, independent does not mean, okay, independent does not mean that they are exclusive. Intersection happens, okay, intersection happens. It is just intersection is probability of A into probability of B. Okay, now if you want to understand all of three using the matrix method, say you don't want Venn diagram, you don't want formula, you want to understand the matrix method. So we have A, A naught total, B, B naught total, right? Now what happens for mutually exclusive events? Okay, this becomes 0, right? This is for mutually exclusive events. Okay, this will become 0 and the rest will remain the same. This is always 1. Okay, if you have mutually, say, exhaustive events, right, then this will become 0. Okay, this means the events are mutually exhaustive. Okay, there will be a value here, 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 this will again remain 1, right? Mutually exhaustive means the neither becomes 0. Okay, and independent event means this, right? This will be probability of A into probability of B. This will be a product of these two. Similarly, this will be a product of A naught into probability of B. This will become product of A into B naught. Okay, all the four values will come, they will simply be product of the totals. Okay, so if you want the same in matrix method, this is how you can represent it. Okay, so I hope you are able to understand the concept of two variables. The same can be applied to three, right? Now let's jump into the questions. Alright, so what do we know here? We know two cards are drawn from a standard deck of 52 cards. Both are red or both are kings. Okay, so we have a standard deck of 52 cards, right? Those of you who do not know, right, learn or get to know cards. Okay, there are total 52 cards in a deck. Okay, which are divided into two colors, right? Black and red. Okay, Black are then divided into two, that's spade and clubs, and you have 13 of each. Okay, similarly red are divided into hearts and diamond, and again you have 13 of each. Okay, now what do we have here? We want probability that either both are red or both are kings, right? So I will say let event A be both red. Okay, let event B be both king. Okay, now I want either A or B, right? I want probability of A or B, right? Now if you're doing formula, if you're somebody who wants to use the formula, this will simply become A union B, which is probability of A plus probability of B minus probability of both. Okay, probability of A is favorable case, I want both red. Again think, what should we use here? Repetition not allowed, order does not matter, so it is combination, right? So it is combination. So total cases 52C2. What do I want? Both red. Favorable cases 26C2. Right? Now probability of B is both king. Again total will remain 52C2. Both king means 4C2 minus both. Both means it has to be red also and king also. Right? So red and king. Again total 52C2. Red also, king also means there are only two cards. So 2C2. Okay. Now all you have to do is solve this. 26C2 will be 26 into 25 by 2 plus 4 into 3 by 2 plus 2 into 1 by 2. Sorry, minus by 52 into 51 by 2. Okay. If you solve that, that's 13 times 25, 325 plus 6 minus 1 by 26 into 51. Okay, this if you solve is 330. Okay? This if you solve is 330. 26 times 51. Okay, now if I cancel, right, I can cancel by 3, that's 110. Cancel by 3, that's 17. Cancel by 2, 13, 55. If you solve, that is 55 by 221. Right, 55 by 221. Okay, so remember, all you have to do is read the question. Okay, read the question and figure out what is it that they are looking for, right? And remember, just apply the same method, right? And you will get the answer. Alright, let's look at the next one. So we have probability event X occurs 0.6, probability event Y occurs 0.3. They are independent events, right? Important, independent events. Neither X nor Y occurs, right? So if probability of event X is 0.6, then probability of not happening of X will become 0.4, right? Because it is 1 minus 0.6. Similarly, probability of event Y is 0.3. So probability of not happening of Y is 0.7. Okay. And we want neither. Neither means X is also not happening and Y is also not happening. Now since these events are independent, this simply becomes probability of X naught into probability of Y naught. Okay, which is 0.4 times 0.7, 0.28. Okay, remember independent does not mean that they won't happen together. Independent simply means happening of one has no bearing on happening of the other. Okay, it is exclusive events which cannot happen together. Okay, now here itself, see, if you try to make the table, right, I'm just showing you how to use the table, right? This is very direct. Not x into not y gives you the answer. But suppose there is some other question and we are supposed to make a table. So how will the table work? So you will write x not x total, y not y total. Right? X is 0.6, total is always 1. Y is 0.3, this will become 0.7, this will become 0.4. Right? So if they are independent events, this simply becomes x into y, 0.6 into 0.3. Okay, it simply becomes x into y, which is 0.6 into 0.3. Right, this is 0.6 into 0.3. This value again total into total, 0.3 into 0.4. This value 0.6 into 0.7, 0.4 into 0.7. Okay, so in case of independent events, the each element of your table simply comes from the product. Okay, alright, moving to the next one. So we have library contains 200 hardcover, 500 paperback books, fine. 50% and 60% are fiction, books selected at random, probability that it is neither paperback nor fiction. So again, the moment we read it, we realize there are two variables here. So one is type of book, hardcover, paperback. Other is genre of the book, fiction, non-fiction. Right? So the moment you see this, the table can come to your mind. Right? You can apply the formula, or as I said, I particularly find table very easy to solve. So I'll make the matrix like this: paperback, hardcover, total, fiction, not fiction, total. Total is 1. Sorry, it's not probability, we just have numbers. Total hardcover is 200. Total paperbacks are 500. So total is 700. Okay. Then we have 50% of hardcover books. Right. 50% of what? Of hardcover books. That's 200. Right. 50% of hardcover books are fiction. Similarly, 60% of paperback books, right, are fiction. So if you just complete the table, total fiction are 400, this is 500, 300, so 200, 200, 100, so 100, 200. My total matches on both the sides, so all my values are correct. Now what do I want? The book is neither paperback nor fiction. So not paperback means this is gone, not fiction means this is gone. This is what I want, right? This is what I want, right? That is 100 over total, which is 700, 1 by 7. Okay. Alright. So here we know, right, here we know that the first 2 months, the probability that fish will not survive is 1 by 10. Okay. So surviving will become 9 by 10. We have a number 300 new fish are observed. How many are expected to survive after first 2 months? Okay. So what do we have? We have probability fish dies or does not survive as 1 by 10. That means the probability that fish survives will be 9 by 10. Okay. Now we have 300 newborn fish. Okay. The question is, how many of these are expected to survive after the first 2 months? So right now we have 300. After the first month, surviving will be 9 by 10. Okay, right? Don't rush, no need to solve this, keep it as it is, right? Then whatever is left, right? Whatever is left after another month, again 9 by 10 of these will survive. Okay, don't just think that okay, 1/10 means 30 are going to die. Okay, so first month 30 die, next month again 30 die, so 240 left. Wait, we should have kept an option as 240, right? Remember, it's 1/10 of whatever are left, okay, that are dying. So 300, 9 by 10 will survive. Whatever this number comes, 9 by 10 of that will survive again. Okay, now you solve. This is 243. Okay, now if you solve, this is 243. Okay, all right. Interesting question. So see, the probability of selecting without replacement, this is important, right? Two green marbles containing only green and yellow is 3 by 55. So probability is already given to us, right? There are 3 green marbles, total number of marbles. Okay, fine. Right. So what is happening here? We have probability of selecting 2 green marbles. Okay, so the favorable cases are to get 2 green marbles, right? What is probability? It is favorable cases by total cases, right? So we have favorable cases are to get specifically 2 green marbles. Total cases are getting 2 marbles from total. Doesn't matter what color they are, right? So now again, repetition allowed? No. Order matters? Again the answer is no. So we know we have to use combination here. Now, step number 1, always go for total. Do you know total number of marbles? No, that is what we have to find. So let that be T, C2. Okay, because I need 2 out of total. Favorable is I need 2 green. I have total 3 green. Favorable cases are 3C2. Right? Probability is already given to me. Right? Now we just solve. Right? 3 by 55 is 3C2 is 3. Okay, TC2 is T factorial by T minus 2 factorial into 2 factorial. Okay, if we simplify this, that's 3 over. Now T factorial can be written as T times T minus 1 times T minus 2 factorial. Right? This T minus 2 factorial cancels out. Okay, if you simplify it further, this is 3 over T into T minus 1. The 2 factorial goes on top. Right? Flip and multiply. So we have 3 over 55 as 6 over T into T minus 1. If you solve that, again 3 and 6 cancel out, right? Cross multiply, T into T minus 1 is 110. Okay, now don't just rush. Okay, don't just rush and say, oh, T into T minus 1 is 110. Do the quadratic, T square minus T is 110. No, just think, what is T and T minus 1? These are two consecutive numbers, right? What are T and T minus 1? They are two consecutive numbers. So let me break this 110 also into consecutive numbers. Okay, don't just rush and solve quadratic. Okay, you can do that, you will get the answer. But how do you speed up the process? How do you make life easier for yourself? Right? Break this 110 into product of two consecutive numbers. Right? It is 10 into 11. Right? It is 10 into 11. Now, which one of the two is greater? T or T minus 1? T is the greater number. Which one of the two is greater? 11. So we know T has to be 11. Okay, t has to be 11, t minus 1 will become 10. Okay, moving to the next one. Child rides one of 5 different roller coasters. Okay, fine. And the child rides 5 times. What is the probability that each ride he will ride or she will ride each ride exactly once? Alright. So again, what is it that we want? We want the probability that child rides each ride exactly once. Right? So that is again, don't worry, just think what is probability? Favorable case by total case. Favorable is each ride once. Total means ride any number of times. Okay. Now again, focus on finding total cases first. Think, is repetition allowed? Say you are the child. Okay, there are 5 roller coasters. You are the child. You can repeat, like you go for roller coaster number 1. You like it. You want to repeat it. You can repeat it. So repetition is allowed. Now since repetition is allowed, we use counting. Right? Now the child is riding 5 times. So I'll make 1, 2, 3, 4, 5 spaces. First time he has 5 options or she has 5 options. Again, second time also 5 options. Fourth and fifth time also 5 options. Right? Why did we go for counting here? Because repetition is allowed. Now, what is the favorable case I want? Each ride should be done exactly once. That means repetition should not happen. Again, but because I have used counting, I'll continue with counting. Okay, because I have used counting, I will continue with counting. Right? First time, pick any ride or pick any roller coaster. Second time, you can't repeat. So 4, then 3, then 2, then 1. Okay, if you solve this cancels out. That's 24 over 625. Right, 24 over 625. Okay, again remember and read the question, break it into simple parts and then solve. Okay. Alright, continuing with the same, we have a similar question. The probability that customer purchases a muffin is 0.8. 5 customers visit. What is the probability exactly 4 will buy a muffin? Okay, so say you are the barista or you are at the counter. Okay, 5 customers walk in. You need to find what is the probability that exactly 4 of them purchase a muffin. So I'll say fine, no problem. Right, what is the probability that I want? I want exactly 4 to purchase muffin. Right, all right, no problem. Now let me think. Repetition again not allowed because the same customer can't purchase again and again. Right, does the order matter? No. Right, you, like the first one picks muffin, second one picks muffin, third one, it doesn't matter. All I want is 4 out of the 5 to pick muffin. Right, and exactly 4, not just like minimum 4, exactly 4 of them. So what I do is I'll say okay, out of these 5, okay, I have 5 customers here. Out of these 5, okay, let me pick 4. Okay, from these 5 let me pick 4 and I will give muffins to them. Okay, I will see the point of probability, or as we discussed in permutation combination, is you are supposed to make sure this happens. So then how do we ensure that? Okay, so we have 5C4. From 5 I am picking 4 and I will give muffin to them. Okay, so I pick 4. Now all of them need to compulsorily purchase a muffin. So that is 0.8 4 times. Okay, because out of these 5, 4 will purchase muffin compulsorily. Now the fifth person, right? I'll pick that person. 4 I picked, I gave muffins to them. They are gone. One person is left. I'll call that person. This person, I will not give a muffin, right? Now not giving muffin is 0.2 because muffin is 0.8, so not giving muffin will become 0.2, right? Now since we have directly used probability here, there is no total case, okay, because I have taken probability directly, okay. So this is simply, now 5C4 means 5 into 0.8. Now since the answer are in fractions, I'm converting everything into fraction. That's 4 by 5 power 4 into 1 by 5. This 5 and this 5 cancels out. That's 4 by 5 power 4, right? That is 256 by 625. Okay, so if you see, this is not it, this is not it, this is not it. If you simplify the first option, so you can cancel this by 4, right? If you simplify this option, cancel this by 4, this is 256 by 625. Okay. Alright. Now another way of solving this, okay, another way of solving this is, see, these are all independent events. The first person purchasing a muffin has nothing to do with the second person purchasing a muffin, right? So if you're thinking in that terms and you want to count for yourself, so you can do that first person purchase a muffin, second muffin, third muffin, fourth muffin, fifth muffin not, right? You can do like this, but then you have to count, see, because you're counting cases here, then you have to count all possible cases, okay? So you can say that, okay, this one does not purchase, what if this one does not purchase, right? Which simply becomes m into m into m into m naught into m and so on, right? Which is essentially, right, which is essentially m into m into m into m into m naught times 5, okay, which is same as what we got, that is 4 by 5 into 4 by 5 into 4 by 5 into 4 by 5 to 1 by 5 times 5, okay, which is 256 by 625. Okay, so again, as I said, it simply depends on your approach to the question. If you think these are independent events, if you think you want to count cases, if you're counting cases, then count all of them. If you think that no, order doesn't matter, let me just look at it as a complete whole, then you can use combination. Okay, so it completely depends on you. Okay. Alright, moving on to the next one. It is similar to what we did just now. So we have applying for 3 summer internships, selects a random by lottery, probability of selection is 30%, at least one. Okay, so the point is she gets selected to at least one. Again, these are independent events because the first college selecting her has nothing to do with second college selecting her or not, right? So this is independent events. Okay, I hope we understand this. Again, it says you get selected or get accepted into at least one, so you can do make cases, right? What if she gets selected to exactly one? Then she gets or, right, or gets selected to exactly 2 or gets selected to exactly 3 or all 3. Exactly 1, again, if you're thinking in terms of counting, that will be selected into not selected into not selected, but there are 3 such cases. Remember, if you are counting, then you have to count all cases or count all possibilities. Exactly or means addition, exactly 2 means selected, selected, not selected, again 3 such possibilities. Or means addition, selected, selected, selected. Okay, if we solve this, that's 30% into 70% into 70% into 3, 30% into 30% into 70% into 3. This is 30% into 30% into 30%, right? And now you just add all of these, right? That is 7 into 3, that is 21. 21 square is 441. Okay, 3 zeros are gone, so that's 441 by 1000 plus this is 3 into 3, 9 into 21, right? 9 into 21 is 189 by 1000. 3 into 3 into 3, that's 27 by 1000. Okay, that's 630, 657 by 1000. Okay, or else, right? Or else, see, we have done this before. Whenever they say at least one, another way to think is you do total minus none, right? We can do total minus none, right? Total cases minus she does not get selected at all. If I remove those cases, that means she is getting selected somewhere, right? Total, we know probability is 1. None means not getting selected anywhere. That's 70%, 70%, 70%. That's 1 minus 343 by 1000, 657 by 1000. Moving on to the next one. So a box has 5 red and 4 white balls. 2 balls are drawn. One is red, one is white. Okay, an interesting question. See, it looks easy, but it's an interesting question. And just give me a couple of minutes, I'll tell you why. Right? Again, as I said, in our mind, we think of different methods. Right? Somebody might think, okay, I'll do counting. Right? Somebody thinks, let me do combination. Right? So let's figure it out. As I told you, it's all mental. Okay, it's all mental. So if you want to do counting here, right? If you are somebody who thinks that no, I will count cases, right? The question says I want one red and one white. So if you are doing red into white, okay, and if you just stop here, so red means total you have 5 red out of 9, so that is 5 by 9 times white is 4 by remaining 8. Okay, if you are somebody who's thinking no, I'll do counting, probability of red into probability of white. I need one red, I need one white. I got red into white, 5 by 9 into 4 by 8. That's it. If you stop here, right, you'll make a mistake. Okay, you get the answer as 5 by 18, right? We are evil people. We have put that as an option. Okay, but you have made a mistake because, as I said, whenever you are doing counting, you have to count all cases. Okay, you have to count all cases. What does that mean? See, it is equally possible that the first ball is white and the second ball is red, right? And you get 4 by 9 into 5 by 8, which is again 5 by 18. You have to have both the cases, right? So your overall answer becomes 5 by 9. Okay, so if you are somebody who wants to count, remember, whenever you count, you have to count both the cases or all possibilities. Okay, now if you have been watching these videos, you will realize we don't prefer this. Okay, for this question we won't prefer this. What will we say? Repetition allowed or not? Not allowed, right? Order matters? Does not matter. I just want one red, one white. Order does not matter. So we will go for combination here. Okay, we go for combination here. I want one red and one white. That's favorable. By total, total is simply get 2. One red is 5C1, one white is 4C1, total 9C2. From 9 pick any 2. Now if you solve that, that is 5 into 4, 9C2 is 9 into 8 by 2. Flip and multiply, 5 into 4 into 2 by 9 into 8. This cancels out. Answer is 5 by 9. Okay, answer is 5 by 9. Okay, so remember, if you are counting, there is no problem, but then count all cases. Okay, or else Just understand when to apply what. Apply combination here. Order doesn't matter, right? Just apply combination. You won't be worried. Okay. Moving on to the next one, right? This is sort of straightforward. There are 10 volunteers. Raj and Priya are included in that. 5 are to be selected, right? What is the probability? Raj is there, Priya is not, right? So again, we want probability. Raj is present, Priya is not present, and I need 5 members, right? So again, probability is favorable cases, right? Favorable cases, Raj present, Priya not present, and because Raj is present, I need 4 more members. Divide by total. Total is 5 members, right? Total is 5 members, right? Alright. Again, look for total first. Repetition not allowed. Order does not matter. So from 10, pick any 5 combination. Now Raj is compulsory. Favorable case. Priya cannot come. So what is left? 8 people are left. From those 8, I need 4. From those 8, we need 4. So that is 8C4 over 10C5. That's 8 factorial by 4 factorial into 4 factorial. 10 factorial by 5 factorial into 5 factorial. Okay, don't try to cancel and all. Simplify it, right? This becomes 8 factorial into 5 factorial into 5 factorial by 10 into 4 into 4. Okay. 4 factorial, 5 factorial cancels 5. 10 4 factorial cancels 5. 8 factorial, 10 factorial cancels as 10 into 9. 5 and 10 cancel out. 5 by 80. Okay. Another question, very similar to what we did just now. So probability that event P occurs is 1 by 4. Experiment is conducted 4 times. Probability P occurs exactly twice, right? So again, if you're thinking counting P, P, not P, not P, but then again you will have to count cases, right? You will have to count cases. Instead of that, let's simply do combination. See, there are total 4 cases, right? 4 times, right? From those 4 times, any 2 times, right, P will happen. From those 4 times, any 2 times P will happen. I don't know what is the order. Could be first 2, first, third, second, fourth, third, fourth, whatever. From 4, right, which are your 4 events, pick any 2 when P occurs, right? Probability of occurring of P is 1 by 4 into 1 by 4. Okay. Now those 2 events are done. Now from remaining 2, okay, I need both the events to happen, and in those events compulsorily P cannot occur, right? See, probability of P happening is 1 by 4. So probability of P not happening is 3 by 4, right? From these 4, right, from these 4, any 2, right, P will happen, and the remaining 2 compulsorily P should not happen. So from 4, pick 2 first. Which 2 when P is happening? P is happening. These are all independent events, right? So multiply. Now remaining 2, you have to compulsorily make sure P is not happening, right? And now we simply solve this. 4C2 is 6. 1 by 4 into 1 by 4 is 1 by 16. That's 9 by 16, right? That's 54 by 256. 27 by 128. Okay. Alright. Looking at the next one, we have 6-sided die is rolled twice. Okay, probability that number on first roll is greater than number on second roll. Okay. Again, don't just jump, think. Can repetition happen here? Yes, because when you roll a die, the same number can come again and again, right? Same number can come again and again, right? So what we do, we need probability that answer for the first is greater than answer for the second, right? Which is favorable case by total cases, right? Now again, we always go for total cases first. Die number repetition is allowed, so we will go for counting. Die number 1, 6 options. Die number 2, again 6 options. Okay, does that make sense? Now first roll has to be greater than second. Since we know we are counting, let's actually count cases. Say first roll is, like this is first roll, this is second roll. So first roll can be 1, 2, 3, 4, 5 or 6. These are the options, right? 1, 2, 3, 4, 5, 6. If the first roll is 1, there is no way second roll is less than the first, right? If the first roll is 2, there is only one case, 2 and 1, right? When the second roll is less than the first. If the first roll is 3, likewise 2 cases, 3, 1, 3, 2. If first roll is 4, 3, similarly, right? 3, 4, 5. So these are the total cases when, right, the first roll will be greater than the second. If I add them up, that's 15, right? So we have 15 over 36, it's 5 over 12. Okay, remember, because repetition is happening, go for counting. It will be easier to solve. Okay. Moving on to the next one. Again, 3 gold, 7 silver, 3 coins are selected without replacement, right? Probability exactly 2 are silver. See, this is very similar to a question that we did just now, right? The red and blue, the red and white question. Okay, those of you who go for counting here, those of you who say that we will do silver, silver, gold, right? Remember, you will have to count all possibilities, right? The all possibilities will be silver, gold, silver also, and gold, silver, silver, right? If you are thinking that no, I will do silver, silver, gold, no problem, that's counting, right? Because you're counting each step, no problem, do that. But remember, whenever you are counting, count all cases. Okay, count all cases, right? Right, so if you are doing, right, if you are doing silver, silver, gold, then count all cases that it could be silver, gold, silver also, and gold, silver, silver as well, right? Or just solve for 1 and multiply by 3, right? So if you are doing silver, silver, gold, that is 7 by 10. Now that we have one silver, second silver will be 6 by 9 and gold will be 3 by 8, and multiply this by 3. Okay, so if you are doing counting, no problem, do that. But then this is what you have to do. You have to count all cases. All right. Again, those of you who are thinking of combination, that's the order doesn't matter. I just want 2 silver, I just want 1 gold. Doesn't matter what it is, what order it is, right? Then what we will do? We simply do probability of 2 silver, 1 gold is total, that's 10C3. Okay, total is 10C3. 2 silver is 7C2 and 1 gold is 3C1. If you solve that, 7C2, right, that's 21, 3C1 is 3, 10C3 is 120. Okay, that's 21 by 40, right? That's 21 by 40. So if you're thinking like this, as I said, you don't have to worry. You will never be concerned about, oh, did I consider all cases or not? Okay, everything is considered here. Let me just solve that. right? To make sure that we get the same, this is gone, right? 3, 4. Again, if you solve, that is 21 by 40, right? So again, guys, there is no one single correct way. It simply depends on how you think. If you are somebody who wants to count, remember, whenever you count all cases, okay? Whereas if you think that, see, order doesn't matter, it's just 2 silver, 1 gold, I don't care where it is, right? Go for combination, directly apply, you'll get the answer. Alright, moving to the next one. See, we have first bag contains 5 blue and 6 marbles of other colors. Bag 2 contains 4 blue and 7 marbles of other colors. So we have bag 1, bag 2. I have 5 blue, 6 other, whereas here I have 4 blue, 7 other. Okay. Now 1 marble is selected from each bag. Okay, no problem. 1 is selected from each bag. What is the probability? Exactly 1 is blue. Okay, I want exactly 1 to be blue, right? Fine, no problem. Say we are going for counting here, right? So I will do blue from the first one, something else from the second one, or something else from the first one and blue from the second one. This is how I am ensuring, right? This is how I am ensuring that I get exactly 1 blue. Now, since these are 2 different bags, these are independent events, what happens here has no bearing on this, right? Blue on the first one is 5 by 11, other on the second one is 7 by 11, plus other on the first one 6 by 11, blue on the second one is 4 by 11. If you solve this, that's 35 plus 24, that's 59 over 121. Okay. Alright guys, I hope you were able to understand the concept of probability. Guys, please don't be scared of this topic. Remember, it's simply favorable cases by total cases. We already know, we have done permutation combination counting. We know how to find favorable, we know how to find total. Then we just have to divide the two. Okay, I hope you understand this. Right? I'll see you in the next one. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.